and today I am excited to present my project titled Home Automation using Blynk Control and with Arduino. So in this video, I will be explaining the objective and working and the real-time applications of this project. Let's get started. So in today's world, automation plays a key role in enhancing comfort, energy efficiency and safety. So the main goal of this project is uh, to design a smart home system that allows users to control and monitor household devices remotely using uh, Blynk IoT Platform and an Arduino microcontroller. So coming to objective, the objective of this project is to build an intelligent home that can automatically adjusting lighting, control temperature, and manage your water levels, all while allowing remote access from a smartphone. It means it adjusts the light brightness based on the light using an LDR, dynamic lighting control, and then monitors the water level in a tank and controls the inlet valve automatically, and maintain the room temperature by automatically switching on or off a cooler or heater. So it's providing a real-time updates and manual control using the Blynk app. So the system helps to reduce energy wastage and it minimizes human efforts and increases convenience. So next, let us see the system architecture and the data flow. So in the system architecture consists of sensors, Arduino Uno, Ethernet module, and Blynk Cloud, and user interface via the Blynk app. It's very user interface user Blynk using. So sensors like LDR and LM35 and water level sensor continuously collect real-time data. So these sensors collects the real-time data. The Arduino Uno processes the information and decides the necessary action. For example, to turn on or off a device that are providing Arduino and Blynk Cloud. Data is then sent to the Blynk Cloud, which updates the mobile app interface. So the user can monitor or manually the operations from anywhere using the internet. A 16 to 2 LCDs also displays sensor data locally. So ensuring the system works even if the network fails. So next we will see about core components. That means hardware components. The project uses affordable and easily available components like Arduino Uno and LM35 temperature sensor and Ethernet module, LDR, water level sensor, and 16 into 2 LCD display. So Arduino Uno acts as the central controller, processing sensor inputs and executing control logic. And then LM35 temperature sensor provides accurate temperature readings for climate control. And then Ethernet module. It uses as a connectivity layer. So Ethernet module enables the internet connectivity between Arduino and Blynk Cloud. LDR, light dependent resistor. It detects the light intensity and water level sensor monitors the tank water levels. And then LCD display shows the temperature and water level and system status. So next we will discuss about working principle. Smart automation logic. What is a smart automation logic? What logic will be considered in this? So lighting control. First one, yeah, temperature control. Temperature control means the LM35 sensor measures the room temperature. If the temperature goes above 35 degrees centigrade, the cooler relay turns on. When the temperature falls below the threshold, the heater is activated to maintain comfort. So next, the water level. Water level in the tank level management, that means water level control. The water level sensor detects tank capacity. When the level drops below 2000 liters, the inlet valve opens automatically to refill the tank. So Next, we will discuss about Blynk app integration. What is meant by Blynk app? The Blynk app IoT platform is the bridge between the hardware and user. It is a very most useful user-friendly platform, and the app allows real-time monitoring and control using virtual pins. Okay, that map to Arduino functions. The virtual pins are maps to the Arduino functions. So widgets used buttons. We are using the widgets buttons and gazes and LCD widget and notification widget. So uh, buttons for manual control of heater, cooler and values, we are using buttons, and gauges uh, displays the temperature and water level in real time. For suppose the temperature in up to 100 degrees temperature, and the volume gauge is up to 3000 liters, and LCD widget shows current system status. So okay, and then next, coming to a software and code overview, the project uses Arduino IDE for programming. We are using Arduino IDE. The code is written using uh, Blynk software, and Blynk write handles input commands from the mobile app, and Blynk timer schedules periodic data and uploads without stopping the main program, and handle temperature. It manages the temperature logic, and handle tank automates water level control for suppose 2000 liter minimum. So let us see output and verified results. After successful implementation, uh, the system was tested under the various conditions. It accurately adjusted brightness, controlled temperature, and managed water levels automatically. All the data was synchronized with the Blynk app in real time. So the system proved as reliable in performance and energy efficiency and easy to use. We are very easy to use the Blynk app, and then fully responsive to user commands remotely. We are also known this. And next, advantages and future enhancements. It means coming to advantages, uh, we have to reduce manual operation through smart automation. It's very useful to our future enhancement purpose also. Water efficiency enables remote access and monitoring from a smartphone, and saves energy and improves comfort, easily expandable for more sensors of features. So it is a intelligent and automatic logic, scalable architecture. So coming to future enhancement, replace the Ethernet module with Wi-Fi for wireless connectivity in future enhancement. Voice assistants. Integrate voice assistants like Alexa or Google Assistant for better user friendly. And use machine learning for predictive control, for example, automatically learning and automatically learning your data uses patterns like and system securities like smoke or motion sensors for complete smart home automation. We have to manage the smart home. Then then conclusion. To conclude, this project demonstrates a successful implementation of IoT based home automation using Arduino and Blynk Cloud. It efficiently automates lighting and temperature and water management while providing full remote access through a smartphone. So for suppose efficient automation, the system successfully automates key aspects of a home environment, from light to climate and water management. Comprehensive remote access. User gain complete visibility, all the complete visibility and control over their home systems via the remote Blynk mobile application, mobile app. So the project not only shows how electronics and IoT can transform modern living, but also serves as a foundation for advanced home automation in future development. So thank you. So let us see our project. So first we have to discuss about the code which we have written in the Arduino. So these this is the code, and first we have to integrate our Blynk app. So we have to use Blynk template name and Blynk template ID, Blynk authentication token. It is required to connect our Blynk software to Arduino. Then next, these are the libraries, including required libraries for communication: Ethernet and Blynk Simple Ethernet, and Liquid Crystal I2C and LCD display. So this LCD Crystal I2C, it creates an LCD object with I2C address 0 cross 27, means 0 cross 27 and 16 comma 2, 16 columns and 2 rows it means. And this also includes libraries. It Blynk timer, it creates a timer object to send data periodically to the Blynk app. It executes Blynk write cooler beeping. It executes when the cooler button is pressed in Blynk app. These are the cooler required code. And cooler switch equal to a param dot as int. These lines are reads cooler state either 0 or 1 and calls the function to turn on the cooler or off the cooler. So LCD print, it displays the cooler state on LCD. So next, Blynk write heater beeping. It means it controls the heater value and updates the heater status on LCD, same as the cooler pin. And Blynk write inlet beeping. It means it turns the inlet on or off and prints the status on LED. It is for the purpose of serial tank. So outlet valve also, it controls the outlet valve through Blynk app. It turns the outlet on or off and displays the states on LCD print. So next, this is the temperature reading. It sends the temperature and water level data to virtual pins in the Blynk app. This handle temperature means in this first handle temperature, it is a function to turn off heater when the temperature exceeds 35 degrees centigrade. So yeah, we will see later in our project implementation. And handle tank, it controls the inlet automatically when the water volume is below 2000 liters. When below 2000 liters, the tank limit, though, so inlet valve is very useful for okay, sorry, the inlet valve pin is automatically controls when the 2000 liter below the 2000 liters in the serial tank. Next, next we have to uh, see void setup. This is the setup function runs once during startup. It all or it initializes sensors, LCD and Blynk connection and sets a timer to send data in every 1 second. This void loop, it controls main loop run and it continuously runs. And these all continuously runs the Blynk, updates readings and handles automatic control for temperature and tank also. And these are displays the temperature and water volume in live on LCD. So first we have to see our connection is there or not. Network connection is there. Okay. Then next we have to go to our implementation. So first we have to open the PICSim laboratory, and in the PICSim laboratory we have to select the modules. In the modules, select spare parts. This is the spare parts, but I have already connected these all, but you have to connect all properly. So in this, okay, let me check. Okay, in these inputs we have to connect LDR input. This is the LDR input, and this LDR input connection is go to properties, and in these properties we have to connect the A0 pin to A1. So this 24th pin connection, and then go to outputs. In this LCD HD 44780 I2C we have to connect. In this LCD, next go to properties and then connect the A5 and A4 pin. So next, LEDs. LEDs means we have to see the brightness, and we have to use the garden lights as LCD. So in this, go to properties, and then we have to require only one LED. So the size is 1, keep there, and go to pins and go to fifth pin, PD3. So okay. Then next we have to put one more temperature sensor is required. So this is the temperature sensor. In this, cooler is having cooler, and these are the pins connected with the first pin, heater pin is connected with the PD4, and the second cooler pin is connected with this, and temperature A0. Next, finally we have to connect the Ethernet shield. So this is the Ethernet, and in this Ethernet, go to properties, and first P3 as connected to 18th pin, and P5 connected to 17th pin, and reset connected to reset, and next 10, 16 and 19. So okay. So next we have to connect one more serial tank. In the serial tank, first we have to configure the COM1, already configured as COM1, and then go to tools. In this serial tank is there. First we have to go to virtual pins, virtual serial pins. In this, I already connected the COM1 to COM2 pair. You have to connect the pair. So next we have to go to tools and serial remote tank, serial remote tank, and then we have to connect the COM2 for serial tank, then connect it. So next keep it there, and then next we have to open our Blynk. This is our Blynk app, and then proceed, then go to PICSimLab. How to implement our project is, go to PICSimLab and loadx file. In this loadx file, our project is displays here, and select it, then open it. So it will work. Turn on the lights, and tank is there, and it is our Blynk app. So it's working. Home automation. First, inflow is on. The inlet valve is automatically on. So next we have to off our inlet valve. So this is the way we have to off our inlet valve. I offed the inlet valve, and next uh, wait. Next we have to on the heater. Then by connecting the Blynk app, we will on the heater. Then the temperature increases. See there, the temperature is increases. This temperature reaches 35 degrees. Then it will off automatically heater. Heater is all automatically off. See, then heater is off. Okay. Next, inlet valve is on, and we have to use outlet valve is on. Then see, outlet valve is off, on, and inlet valve is on. See this. Then we have to off inlet valve. So see this, below the 2000, it will reaches the below 2000, then automatically on the inlet valve. Once more, see, it reaches the 2000, reaches the below 2000, then automatically on the inlet valve. So we have to off the outlet valve and inlet valve also. Now cooler, how it works, let me see. The cooler, we have to on the cooler button, and then it will work. The cooler is rotating. See, okay, this is the cooler pin. We have to on, then it will shows like. Next it will off. In display also, we have to see cooler is off and heater is on. It appears like this: heater is on, cooler is on, cooler is off, and heater is off. Inflow off, and we have to, now we have to on the inflow. So inlet valve is on, then on. Next, outlet valve is on. See, outlet valve on, and inlet valve is automatically on when below the 2000 liter. So this is the volume appears in, like in this also we see the volume. So this is our project. In LDR also uh, we are turning light brightness also. So now see the tank and the Blynk app. So now the heater is on. See, once more the heater is on. It reaches the temperature above 35, then it turn off automatically. Heater offs automatically. Okay, it off. And then inflow button. Inflow is on and also outflow is on. If we are off the outlet valve, then inlet valve is working and it filling the tank. Volume is modified there. So yeah, 3000 outlet valve off here, and it also automatically off the inlet valve after completing the 3000 liters. So this is our project. Our project main theme is we have to maintain our home with smart controlled home. See this green color home automation Blynk app. This green color is shows we are in online. Then this green color is off. Then this appears as offline. This is the tank and the LCD display. And then next we have to modify our values also. And let me check. See, outlet flow on, outlet flow off. After N we are leaving the space. After F also we are leaving the space, and before the H, before the H. Why this is happens means we don't want to overwrite the code. So heater is off. It perfectly shows the heater is off. Then no overwriting is there. So this is our code and our implementation. Blynk controlled home automation using PICSim laboratory. And this is our cereal tank and using Blynk. So thanks for your watching, and thank